All right, let's talk about one of the most powerful, and let's be real, one of the most confusing parts of Kubernetes, persistent storage. You know, if you've ever had a container restart and just wipe out all of your data, you know exactly the pain I'm talking about. So today, we're going to dive in and solve that problem for good.
The whole thing starts with this one simple fact. The file system inside a container is ephemeral. Just think of it like a whiteboard. You can write all over it, do all your work, but the second that container restarts, poof, it's all gone, wiped clean.
Exactly. I mean, if you're running a database or a blog or really anything that needs to actually remember stuff, you can't save it to that whiteboard. You need a permanent spot, somewhere totally outside the container's short little life.
So here's our game plan. First, we're going to quickly pin down the problem. Then, we'll use a really simple analogy, ordering a pizza, to understand how Kubernetes solves this. We'll also touch on the more manual way of doing things, and then finally, we'll see how a pod actually gets to use the storage we've set up.
Okay, so let's put an official name to this problem we've been talking about. It all comes down to the very nature of that container file system. And here it is, the ephemeral file system. You have to understand, this is designed for speed and for isolation, not for things to last forever. It's actually a feature, not a bug. But it's a feature we need a clever way to work around for most of our apps. So, how do we do that? The answer is something called a Kubernetes volume. You can think of a volume as just a directory that gets attached to your pod. The secret is that this directory is backed by some kind of storage that lives completely outside of any one container. It decouples the data's life from the container's life. Now this is where things get really clever. Instead of you having to manually create storage and then figure out how to connect it, Kubernetes has this awesome on-demand system called dynamic provisioning. And honestly, the best way to get it is to think about ordering food.
The whole process is just like ordering a pizza. First, the cluster admin, kind of like the restaurant owner, creates a menu of what's available. Then, a developer, the customer, places an order from that menu. And finally, Kubernetes, the kitchen, automatically prepares and delivers the dish, the actual storage. Let's break down each one of these.
So let's start with the menu, which in Kubernetes speak is a storage class. This is the admin's job. They decide what kinds of storage you can even get in the cluster. You know, maybe there's a premium fast SSD option and a bulk option with slower, cheaper hard drives. Each one of those is an item on the menu, a storage class.
Now, if you look inside one of these menu items, you'll find three really key things. The provisioner is basically the chef. It's the piece of software that knows how to actually cook up this kind of storage. The parameters are the ingredients, like saying you want a standard disk on Google Cloud. And the reclaim policy is about cleanup. When you're done, should the system just throw the dish away, or should it keep it around?
Okay, next step, placing the order. This is where a developer creates what's called a persistent volume claim, or a PVC. This is just them looking at the menu, at the storage class, and saying, yep, I'll have that one. Give me 3 GB of the NFS option, please. They don't need to know how it's made, they just need to know what they want. And that's what makes this so incredibly simple for the user. Their order is just 2 things: the name of the menu item they want, the storage class name, and how much they need. That's it. Kubernetes handles all the messy details from there. And finally, the system delivers the dish, the persistent volume, or PV. This is the real piece of storage that got created just to satisfy that user's order. It now exists as its own resource inside the cluster, all ready to be used.
And don't just take my word for it. The official Kubernetes documentation really drives this home. It says a persistent volume is a resource in the cluster just like a node is. So it's not some little add-on. It's a core part of the infrastructure with its own independent life. So once that dish is ready, this crucial connection gets made. The system binds the order, the PVC, directly to the dish, the PV. Think of it like your name getting written on the pizza box. It's an exclusive one-to-one relationship. That storage is now reserved just for that request. So how does this actually work under the hood? Well, it's this really elegant two-way handshake. The persistent volume, the dish, gets a little note on it that points back to the claim that ordered it. And at the exact same time, the claim gets updated with the name of the volume it successfully got. This two-way link locks them together.
Now, what if you don't want the system to cook for you, right? What if you want to bring your own pre-made dish to the party? Well, that's where static provisioning comes into play. It's the much more manual, hands-on approach.
Let's just compare them side by side. With dynamic, Everything is automated and happens on demand. Storage literally gets created only when a user asks for it. With static, an admin has to go and manually create a whole pool of persistent volumes ahead of time. The user then has to claim one of those specific, already existing volumes. So dynamic is way more scalable, right? It just reacts to demand. Static is more rigid, but it's absolutely essential for when you need to connect to an existing storage system, maybe like a big on-premise SAN that you've already paid for.
Okay, deep breath. We've ordered our storage, it's been delivered, it's bound to our order. Now for the most important step of all. How do we actually serve this dish to our application that's running inside a pod? It's actually a really simple two-step process inside your pod's configuration file. First, down in the volumes section, you just declare, hey, I want to use the storage that's tied to this claim, and you give it the name of your PVC. Then, second, up inside the actual container spec, you say, okay, take that volume we just declared and mount it inside my container at this specific path, like /data or /var/www/html.
And this is where it all clicks. Imagine you have a shared volume, like NFS. You could have 2, 3, 10 pods all using the very same persistent volume claim. This means they are all reading and writing to the exact same underlying storage. One pod can write a file, and another pod can instantly read it. It proves the storage is truly persistent and completely separate from any single pod.
So look, if you remember just one thing from all of this, let it be this. The absolute genius of the Kubernetes storage model is this total separation between the request for storage, the PVC, and the physical piece of storage, the PV. A developer only ever has to ask for what they need. The administrator is the one who worries about how to provide it. This abstraction is what makes everything so portable and so flexible.
This whole model is just so powerful for solving the problem of connecting data to our apps. So as we wrap up, I'll leave you with this question. Now that we have a reliable, automated way to give our applications a place to store their state, what's the next big challenge? What about managing the state itself? How do we start thinking about backups, migrations, and disaster recovery in this new world? Thanks for watching.